Okay, ladies and gentlemen, so this is flipped lesson number 77A, absolute value equations. This is a review topic from algebra that you've covered years ago in getting ready to start working with absolute value inequalities in the following lesson. So if you remember back, absolute value is talking about your distance a number is from 0. So the absolute value of x is equal to 3, means that your value is either -3 or 3. In the examples, as we will go through some together, and the worked out examples we have, you can see that you have to make sure you take in consideration both the positive and negative values as you are going through. It is important to make sure you check each for extraneous roots, as you can always have an extraneous root happen. So let's turn from page 1 now, and let's go past page 2, which has our examples, worked out examples, page 3 has more worked out examples, on to page 4, where we actually have our examples to try together. Okay, so looking at example number 5. Example number 5 says x plus 3 inside the absolute value is equal to 9. So that means we have x plus 3 equal to 9, and we have x plus 3 equals -9. Solving them simultaneously will allow us to get both answers and then check both. As I go forward here, -3, -3, -3, -3. X is equal to 6, x is equal to -12. And if I have two answers now, I need to make sure that they work, or find out if they do work, it would be even better, because either one or both might get rejected. Now they both might work, that is totally a possibility that both will work, but we need to make sure. So we substitute back in our original, x plus 3, the absolute value of that equals 9. The absolute value of 9 is 9, I agree with that. -12 plus 3 equals 9. The absolute value of -9 is 9, I agree with that. So my solutions are 6 and -12. And the order which you write them is not important, I put in a little set notation for you. The trickier ones are ones like number 2, or I should say number 6, excuse me, the second example we're going to try here together. This involves a variable on the inside and a variable on the outside. So what happens here is not only do I have 2b minus 4 equals 2b minus 4, but I also have 2b minus 4 equals -2b plus 4. Okay? And now what happens is you're going to get this situation here. Well, this is the same on both sides. So if I add the 4 to both sides, 2b equals 2b. b is going to equal all real numbers. Okay, because no matter what I put in for b here, but is it really all real numbers? Think about this. This is going to give me all real numbers, but will all real numbers actually work here? Okay, if this value comes out to be negative, its absolute value is going to be positive. So is this going to work here? Well, I don't know. We're going to have to find out. Solving on this side, I add 2b here, add 2b here, and I get that it's 4b, add this 4, equals 8, and b here equals 2. Now, that's much easier to try out if b equals 2, because we can plug in 2 and see if 2 works. The problem becomes this. This answer here, all real numbers, means that this number inside here and this number inside here would end up being the same, and that's true, but once I put the absolute values of that, all of the negatives will turn positive. So I need to know when this number here is still positive. So there's going to be a point where I cannot go any further with the negative numbers going in. So while we're going to check 2, and that's fine, let's check 2. Sorry about that. 2 times 2. 2 times 2 minus 4. So 0 equals 0. That works. This is good. We like this guy. I know that I need to keep 2b minus 4 positive. So let's set 2b minus 4 equal to 0 here, because we're dealing with this. We don't have that for sure. So 2b equals 4 and b equals 2. So that b equals 2 is given right here as well. So we know that works. Pick something bigger than 2. Let's try a number like 10. So if I tried 2 times 10 minus 4, the absolute value of that equal to, oops, sorry, ran out of room there, minus 4. So 20 minus 4 is 16. The absolute value of 16 equals 16. That works. Let's try something smaller. So let's try 0. 2 times 0 minus 4, the absolute value of that equals 2 times 0 minus 4. This is going to be negative 4 inside the absolute value, and this is going to be negative 4, which we know does not work. So my solution set here has to do with that too. I need my values of b, so it's going to be numbers, values of b such that b is greater than or equal to 2, and that's what's going to work here. Even though this is not an inequality, every value greater than or equal to 2 is going to yield a positive answer, or 0, or a positive number inside the absolute value, and that will give me exactly what I need. This is the hardest case you deal with when you have variables on the outside. They won't always be like this, but this is a perfect example of seeing what could happen. Now, with number 7, there's a number on the outside that's being added, so I subtract it off. If you think of this, what's happening here is that 5 is your vertical shift up 5. Okay? So I'm left with the absolute value of 3x minus 1 is equal to, in this case, negative 2. Now, we know when we look back at our previous examples, there's no way anything can work here. We can solve this out and show that it fails, but there's never going to be a case where the absolute value equals something negative. So let's try it anyway. 3x minus 1 equals negative 2. And 3x minus 1 equals positive 2. Add 1, add 1, add 1, add 1. 3x equals, and this is going to be negative 1, so x will equal negative 1/3. And here 3x equals 3, so x equals 1. Let's plug them in and see that they fail, because they will both fail. So it's 3 times negative 1/3 minus 1 plus 5 equals 3. Sorry, let me just put a little line here to show that that's not part of this. That's negative 1 minus 1 plus 5 equals 3. The absolute value of negative 2 plus 5, well, this is not going to work. 2 plus 5 is not going to equal 3. So this gets rejected. Then I'd plug in the 1. 3 minus 1 plus 5. So absolute value of 2. This is not going to work either. This will also fail. So you right here, this is no solution, which totally can happen, as we know. Okay. And the last example gives us a dilation on the outside, okay, multiplying by 5. We're dilating this. Again, it's also being shifted right too, if you think about it in terms of transformations. But I divide by 5 here, divide by 5, divide by 5, and I'm left with the absolute value of c minus 2. Because I can divide, of course, because the 5 is on the outside. Anything that applies to vertically changing, in this case it's a dilation by 5, this was a shift up. Anything on the outside can be moved because I want to get the absolute value by itself. The same way I got radicals by themselves, or anytime I'm trying to isolate a variable or isolate something, I want to get it all alone, and this will equal 6. Well, this looks much more like the other examples in line with what we've done previously. So what happens now is you get c minus 2 equals 6, and c minus 2 equals negative 6. Add 2, add 2, add 2, add 2. And you're left with c equals 8, and c equals negative 4. Okay? Go back to your original. Always go back to your original. Don't ever, oh, it's okay, Mr. J, I know what I'm doing. Go back to your original. 5 times, and it's 8 minus 2 equals 30. 5 times the absolute value is 6 equals 30. I agree. 5 times 6 is 30. Good. This guy's good to go. Our second one, now we're here, right? We now have 5 times negative 4 minus 2 equals 30. 5 times the absolute value of negative 6 equals 30. 5 times 6 is 30, and that is also good to go. Okay? So what now happens is we have our solution set, and our solution set looks like this. The solution set is 8 and negative 4. Okay. Now, there's an additional page with examples for you to try. This just come after. Nothing here is any different than we've done previously. set up each one the same way, making sure that you account for both the positive and negative case, and you will find an answer key attached for these to the back. If you have any questions, make sure you bring them to class tomorrow. Thank you.